bodies in the solar system. So here are the different bodies in the solar system. The Sun, Jupiter, here's Earth. What happens is, kilometers per second, 18 kilometers per second. So that's not right, 11 kilometers per second. Yeah, how did I read that and say 18? I have no idea. Okay, so 11 kilometers per second, right? So I fling it upwards so that the object is traveling at 11 kilometers per second. So by the time I say 1 Mississippi, it's traveled 11 kilometers, ballpark of what, 5-6 miles. So by the time it takes 3 Mississippis for it to reach downtown Phoenix. If I throw it with that speed, the object will escape the surface of the Earth. Now the moon, you can see that the moon's escape speed is much slower, it's much smaller. So if you throw a rock up at 2.4 kilometers per second, it will escape the moon. So when a rocket lands on the Earth, it's harder for the rocket to get off of the Earth than the same rocket on the moon. You need less fuel burn rate, all that kind of stuff. On the other hand, if you look at an object like Jupiter, right, which is 318 Earth masses. So the mass of Jupiter, the planet, is like 318 Earths. You can see its escape speed is substantially greater than Earth. It's like 6 times that of Earth-ish. 60 kilometers per second. If you wanted to escape the Sun, if you happen to be sitting on the surface of the Sun and you want to escape it, now look at this. You have to fling the rock at 620 kilometers per second. Remember we talked about black holes? So if you had a black hole, then what happened, if you're sitting on the surface of the black hole, whatever that means, what would happen is that the escape speed would be the speed of light. You'd have to fling the object up at 186,000 miles per second before the object can escape the black hole.
Does it have to be higher than light?
It has to be higher than the speed of light to actually escape at the event horizon.
Right.
If you're outside of the event horizon from the black hole, then you can fling it at smaller than the speed of light. The further away you get, the lower the speed that you need to escape. If you get past the event horizon, you need to be substantially greater than the speed of light to escape. So it's completely impossible. So what happens is, anything beyond the event horizon, even light cannot escape. So photons, that's why a black hole is totally black. Any photon, like even this black purse, or whatever it is, satchel, okay. You can see there's some light.
Satchel.
What is it? What would you call it?
It's my camera bag.
Okay, camera bag.
Diaper bag.
It's your camera diaper bag?
Yeah, it was my camera bag, now it's my diaper bag.
Oh, I see. Okay. Perfect. So, light falling on this, you can see that we're able to see different shades on this, because not all of the photons are absorbed. But if this were a black hole, you would not be able to see anything other than just a hole missing, because no light would escape, right? So, and that's basically the same phenomenon. Okay, so that takes us then to the multiple choice questions. Look at the first object. An object is dropped, rather not the first object, but the first question, is dropped and falls freely to the ground with an acceleration of 1g. If it is thrown upwards at an angle instead, its acceleration will be what? Okay, so object, you drop it, its acceleration is 1 gravity, 9.8 meters per second downwards. What if I take this object and fling it up into the air? What's the acceleration after it's left my hand? What is the force acting on it? What is the acceleration due to the force after it's left my hand? So I'm not touching it anymore. Okay, think of this in terms of the force. When I hold the object here, there are 2 forces on the ball. One is my hand pulling upwards, right, holding it up, compensating for gravity downwards. So it's 1 gravity downwards. I let go. What are the forces on the object?
Gravity.
Just gravity. So the moment my hand is no longer touching the object, there's only gravity acting on it downwards. Now I throw the ball up. While I'm throwing, there's an upward force. As soon as it leaves my hand, what force is acting on the object? Gravity. There's no other force in the absence of air resistance and wind and all that, right? So, irrespective of whether the object is stationary or moving at an angle or moving horizontally or moving downwards, it's only gravity downwards that's acting on it, right? Yep. Okay, I'm going to go ahead and